Hi and welcome back to my YouTube channel. So in this video I'm going to be showing you how to carry out a Pearson's correlation analysis. I'll be also generating a table that is a correlation matrix as well as a plot. I will also interpret the data for you. So now let's import the dataset. We go to click import dataset. My dataset is an SPSS file, so I'll select SPSS, click on browse, and then I select the file. The name of the file is data, and I click import. So once it's imported, I need to bring in some of the variables into the global environment. So I have three variables in mind. One is anxiety, the other one is stress, and then I'm also interested in bringing in the age of the respondents. So let's first start with age. So here in the console I type age, data, and then I want to extract age as the variable. So as you can see, age appears here. I'm going to do the same thing with stress as well as anxiety. Now it's time for anxiety to be included. So we have our three variables: age, anxiety and stress. Now the next step is to check for normality, because one of the assumptions of Pearson's correlation is normality of data. So for that we need to do a Shapiro-Wilks test. So here it is, Shapiro.test, and I'll have to do it one by one. So first I'll include age. So if the p-value is greater than 0.05, then we can say that the data is normally distributed. In this case, as you can see, the p-value is 0.07, which is above 0.05, so it's normally distributed. The next variable is anxiety. So I include anxiety here, and again the p-value is 0.21, which again is much higher than 0.05, so we can say that the data is normally distributed. The third variable is stress. So I check for stress, and then again we find that the p-value is 0.3448, which is above the the threshold. So therefore we can say that all three variables are normally distributed. So we can go ahead with carrying out the correlation test. Now, as I said, we are going to be carrying out a correlation test wherein we are going to be producing a matrix as well as a plot. So to produce the matrix or the table in APA style, you need to install a package. So go to packages over here, click on install, and then install this package called APA tables, this one, and click install. I'm not going to be installing it because I already have it in my system. So I'm just going to type library, and then I'm going to type APA tables. So APA tables is loaded. There's also another package that I want you to install, but I'll talk about that later. But first we'll generate the APA table, that's the correlation matrix. So before generating the correlation matrix, we need to create a data frame wherein these three variables are included, because currently we have a data file that has all the variables. So to create a data frame, we'll call it correlation, and we'll type data.frame, here it is, and then we'll include the three variables, which is age, right, anxiety, and then stress, and then hit enter. So up here you can see a new data frame has been created with only three variables. If I click this, you can preview the variables as well. Now that we created a data frame, the next thing we need to do is we need to generate the table, the matrix, along with the correlation values. So for this we need to load the APA tables library from the library. I've already loaded it. So what I'm going to do is I'm going to type APA tables. So once I've done that, the next thing I need to do is I need to basically conduct the test using the correlation command. Let me do this from the beginning. Yeah. So here we type correlation apa.core.table, and then I need to put in the correlation data frame. So that's the data it's asking for. I've done that. The next thing is the file name. Now here it's very important that the file name that you introduce is put in inverted commas, and you also mention the extension file as doc or doc file, because we want it as a Word document. So here I'll call it correlation.doc, right? And then comma, the table number is 1. Just hit enter. So as soon as I do this, you can see that the correlation values have appeared here. The next step is, of course, also to check whether this has appeared in the files. So click on files. So here at the bottom you will see a new document that's generated called correlation. You click on it and it will open, and you can see the correlation values have been automatically generated. Also, there's also a very nice explanation that it's providing. So that's it with the correlation matrices. The next step is to develop the correlation plot. So let's go back to R. So here we will basically kind of install a package called Metan. I have already installed it, but if you want to install it, you need to go to install, type Metan, and then click on install. So I'm going to just load it from the library. So the package is loaded. This will provide us with the wonderful correlation plot, which you will see in a while. So before going into that, we need to first carry out the correlation itself. Remember, what we have generated here is not the correlation value. This is a separate data frame. So to generate the correlation value first, we need to type. We can type something like this, CORR. So here we have to type CORR and then underscore COEF, that is correlation coefficient. Type that, and then here we need to type the type of correlation. First of all, the data that we are using, which is the correlation data frame. So I've included that. The next thing is the type of correlation we want, right? We want a linear correlation. So I'll type all in double quotes, linear. And then the next thing is we type the method. So the method is going to be Pearson. So again in double quote. And that's it. Just hit enter, and you can see that a new correlation value has been created over here. So the next thing is we need to plot this. So what we'll do is first we'll go to plots and wait for the plot to drop. Here we type PLOT and then in bracket the correlation that we have generated, the name of that file, CORR, and just hit enter. So as soon as you hit enter, you can see a beautiful correlation table. The red and orangish kind of colors indicate negative correlation, whereas the violet one indicates a positive correlation. You can see the legend over here, which provides a clear explanation for this. You can also export it as an image, and it's of really high quality, right? You can save it onto your computer as well. So that's about it for generating the plot. Now in the next part of the video, I'll be explaining how to interpret the correlation value. Here we have the correlation matrix here. So basically we can just explain it in a very simple way. We can say table 1 shows the correlation between 3 variables, age, stress, and anxiety. The results indicate that there is a positive correlation between stress and anxiety, whereas there is a negative correlation between the age of the respondents and stress as stress, and then you can say moreover, sorry, there's a typo, yeah, moreover there is a negative correlation between the age of the respondents and anxiety. Then we can also say thus, or we can also say like this, moreover, the results have turned out to be statistically significant. How is it statistically significant? A double star indicates that the values are significant at a 0.01 or higher level, whereas a single star would indicate a moderate level of significance. In this case, all three values you can see a double star, so therefore the results are statistically significant at a high level. Statistically significant at a high level. We can also add this, thus the results, no, we can say thus the research hypothesis is accepted, because remember, the end goal of any statistical test is actually to test the hypothesis. So that's it. This is the simple explanation. This is how I would interpret it. You can of course modify it if you wish to. I hope you found this video useful. If you did, please like and subscribe to my channel for more such videos. Thanks for watching, and bye for now.